My name is Moraitis. I work for the Developer Productivity and Test Platform team. You can call me Nick, like mostly my name is different in different places. I'm here to talk about the multi-arc builds and tests in OpenShift CI/CD, which sounds really simple, like multi-arc and stuff, but I guarantee you that it's not that simple, right? So how can I take something that is really complex with a simple title and make it simple for a like editor? Like today, we are going to do some overview of our infrastructure. We have the CI operator, which is the main responsible component that will run the whole thing. How we are managing the image dependencies, what are our multi-arc goals, how we control the architecture in builds, and of course, how we target the testing across the architectures, right? And how we're doing that, like the multi-arc build process, which is something that OpenShift doesn't even support, and how we are doing that. Few best practices, not that many, because there are not that many best practices, to be honest, right? And key takes away, and if we have some time, Q&A, but I will be available after the presentation, of course, right? So this is our infrastructure. I didn't want to put the exact numbers because you don't care, but you care about the quantity, right? And we have around 11 OpenShift clusters, which is one cluster died this week, but when there is death, there is always life. So we're going to bring another cluster up. There is like a massive image dependency, and you are going to see about that. So many job definitions. The job definitions are just there, waiting for someone to just trigger it, how many times the user wants, right? So it's like around 5,000 executions each month, and 400,000 image builds. You can imagine the cost of the whole infrastructure, right? And the ephemeral cluster is the clusters that the CI operator is constructing and creating across multiple cloud providers. So what is this CI operator, right? Like CI operator is our workflow test engine, which is not only the workflow test engine, it's also running the single test as well. And this is the important tool that because this is what we're using in our infrastructure, and it's completely written for the exact cases that we want in our infrastructure, for the whole OpenShift organization. There are some key capabilities that we need to understand first, and then we can move forward in a way that the user has some capabilities in a way to configure CI operator using some YAML configurations, which sometimes look ugly, but this is just art, you know. It's a unique tool that it's integrating only with OpenShift. You can try to run it on Kubernetes. You will fail because we are leveraging OpenShift native resources as builds, image streams, images, and that makes it like impossible to run the release payloads. So imagine that you have a component that is, your component is an operator or something else, which is like important for you to run it under a new OpenShift cluster. And you have a PR open, and you say, OK, I want to test my stuff, right? We will do that for you. CI operator will just like create a release payload, and then we'll create an ephemeral cluster. I think that you remember the number, like it's like around 5,100 OpenShift classes like every single month, right? And the most complex mechanism in CI operator is the step registry. So what is a step registry? So technically we have step modular workflows that they're in the registry, and then you can take pieces of it and you can construct a pipeline, right? Few things about the step registry, which is something that it's the most bigger burden, actually, in our infrastructure, based on the architecture that we are going to speak today. Step registry is basically three concepts. The step concept, which is, it looks like this, which is beautiful, as you can see, right? And in this configuration, the user can specify the commands, which is the commands is in a different file. Obviously, I didn't put it here. There are so many different mechanisms, also resources, credentials, environment variables, recommendation, many other configurations that a step can use. So a chain technically can use multiple steps. So, this is in order. So this chain will use 3 steps and will just run the whole pipeline, right? Which is like a simple concept as well. And then we come to the workflow. With a workflow, we can do a combination of all 2, right? So you have a workflow that uses 3 phases: the pre-phase, the test phase, and the post-phase. The pre-phase is before the test, like you have your test script, like make a unit, make whatever, like run my E2E stuff. But you want an environment, right? So you will run a chain, you will run another workflow maybe, right? So this is trying to highlight why this is really complex. Because when you have this complex workflows, then you have image dependency tree that will make really hard for you to control the multi-architecture, right? So we have a big image dependency. So C operator is trying to build the images on the fly or use different images that already exist in the cluster, right? So, imagine that when you have a workflow that your workflow wants to run 10 different steps, perhaps in a chain or whatever, but every single step is depending on a different image, and the image needs to be available for your architecture that you want, right? So just imagine that you have a workflow that runs 10 steps, and you want to run that workflow on an ARM node. So you will have to orchestrate the whole thing, all the image dependency tree, to be available for ARM, right? Which is really hard. So the images can come from pre-built based images that we are using. So technically, we have different mechanisms how to introduce a new image in the cluster so you can use it. You don't want to maintain it. Maybe you want to stick with a specific version. kubectl, JQ, YQ, or whatever, utility tools that you want to maintain and run your lead job, your unit job, and your E2E job in ephemeral cluster and stuff. And there is another mechanism that C operator will try to build a new image on the fly, which is technically a Docker file or something more unique in a way that you have a script and then you try to import your images in a different mechanisms. None of those things are completely important, but the important thing for us is that when you have a team and you preserve an image, and then another team wants to use your image, right? So this is how it looks like, right? Some of you are thinking, oh, this is beautiful, but it's not, right? So you can see every blue dot, purple dot, blue, whatever. It's like the image for the OpenShift origin master, the branch master configuration. And all the rest are the parents images that are based on those images, right? So you want to run your job and you have one image, but you have the image dependency tree that you want to make sure that everything is on the architecture that you want, right? So, and if you think that this is ugly, this is our 10% of our infrastructure. I was able to take a screenshot of that image before my Chrome crashed. Like, Firefox didn't, I'm just saying. But, so just keep in mind, like, so you have like blue dots here, and every single dot, it's an image. And you say that I'm okay, my infrastructure works really well, everything is okay. And then you introduce the multi-arc concept. And then you just add an extra dimension, right, in the graph. So you have like a 4, 5, 6 dimension per architecture, right? And yeah, I tried to create an image for the image, like a fixture for the image. And I think that the image can look like this. It's like a monster with multiple heads based on the architecture. Of course, AI generated, I didn't create it. Right? So what we need to achieve? Architecture control and image builds and per arc image promotion. which is technically the same core process, but in different places. You want to have an image and build it and have it multi-architectures in the image. You can see here like OCI compliant manifest list. So you can use the image on any architecture without even caring, right? And of course, we need to have the test execution to be targeted on the architecture. And the step-level architecture control in the step registry needs to be resolved. So how we do it? Like C operator technically resolves all the graph from the configuration and understands what to build technically. So if you have like a unit test, and we know that in that unit test, I want to use an ARM node and run it. Technically, your C operator will understand that I need to build the root image, I build to build the SRC image, perhaps other images that I can use, and then I will need to build on top of that the image A in this example, right? So you need to make sure that we are building that thing for the specific architecture. And how we do it, like in the how we do it in the text execution. Like, let's say that we build the image for ARM, right? And then we schedule the pod, and the pod needs to schedule somewhere, I guess, right? So we are controlling that with a node selector. Now you can use like toleration retains as well, and then we resolve all the images for the pod to be to run. But if this is the key part right here, that if you don't care about the architectures, you say like, I don't care about where my unit tests will run, right? I just leave it in the hands of the administration of the cluster to choose the most cheapest option, I guess, right? So we do not assume any architecture. And we are leaving that to the multi-arc tuning operator, which is like a component that can act as a scheduler that will schedule the pod in the correct place based on the architecture availability. This is the GitHub repository. You want to check it out as well. And how we do it? I hear some thoughts like OpenShift builds don't support it, right? So what we do, we understand that we need to build an image for 2 architectures, 3 maybe, or whatever. In this example, AMD and ARM, right? So what we do, we schedule 2 OpenShift builds, one with a node selector for AMD and one for ARM. Then what we do, we let OpenShift build to promote the image to the image stream, and then C operator will construct a new image with a manifest list included, directly using some API calls directly to the container registry, and then we construct the final image that is like manifest listed. That image can be promoted and used based on the architecture, right? Do not assume the architecture. This is something that we were trying to figure out, where you solved everything, everything was built in the correct architecture, and yet you still see that there are some architecture-related errors. And say, what the hell happened? Well, this happened. Like there are guys, or even me, many times, that I was going and just building the image in the Docker file with wget specific architectures. So in this case, it's better to let Docker to determine the architecture and grab the correct architecture binary from a multi-stage build instead, which is the same happening to the test scripts, right? If your test wants to run something on ARM, and then you go inside your script and say, oh, I need the Yaku in this case, so I'm going to download it, and you download it exactly the AMD 64 binary. So you will have failures when you run it on ARM node, right? So there are some better approaches to be architecture agnostic. So to finalize, some of the takeaways, like do not assume that AMD is the architecture. For many years we were running things in AMD, so try to write your scripts and Docker files to be as portable as possible, and you'll be aware about the architecture that you want to present. And of course, if you want to do a multi-arc build, you will need to orchestrate the whole thing, right? So, thank you very much.